All right, in this video, I want to talk about single replacement reactions. The book doesn't cover this, but it's a topic that I want to introduce for those of you that go on to AP Chemistry or are just curious about some of the reactions you've seen already. So in the single replacement lab, this is one of the reactions that you will have done. And you take a piece of aluminum foil and you're putting it in a copper 2 or cupric chloride solution. So what you may have observed is that a brown coat of metal of something forms on the aluminum, and what's actually happening is copper is forming on the aluminum. So what's happening? Well, this is a classic single replacement reaction that follows this form, where you have A and BC reacting to form AC plus B. So the reaction would look like this. It would be, let's do that in black. I'll just go with it in let's write over this. We have AlCl3, so aluminum chloride, and that is aqueous plus copper, and that is solid. And this is the classic form of a single replacement reaction. Here's our solid copper. This was what was forming on the outside of the aluminum foil, and here we have aluminum chloride. So this is an oxidation reduction reaction. You can probably tell here aluminum has no charge, and here it has a +3 charge. So you can see that it is losing 3 electrons. So it is being oxidized, whereas the copper here has a +2 charge, and over here it has a 0 charge. So it is gaining electrons. So it is being reduced. And this is the classic form of a single replacement reaction. Not all single replacement reactions go to fruition. Let's take a look at one that won't. Here's a reaction where we have the classic form of a single element in a compound, an aqueous solution. But in this case, we would get no reaction. And this is actually also the same result for when I tell a joke. No reaction. The reason there's no reaction has something to do with an element's activity. And it's a pretty complicated concept. I'm going to introduce single replacement reactions now. When we get later into energy, and we can talk about something called Gibbs free energy, we'll talk about why a reaction will or will not occur. But essentially, think of it as attractiveness. And in this case, lithium is much more attractive than sodium. And so the chlorine's all like, I don't think so, to the sodium, and it stays with the lithium. And let's take a look at this activity chart. I'm just going to superimpose the chart over top our problem here. This list, and I've given this to you in iTunes University, the higher an element is on the list, the more attractive or the more active it is. And so what that means is if we have a reaction here, let's look at this first one, copper and aluminum. Aluminum will only replace copper if it's higher on the list. And so we go here and we see aluminum is here. We see copper is here, so aluminum is more attractive, so it will replace the copper. However, if we look at this reaction, we see that lithium is higher on the list than sodium. Sodium is right here. And so since lithium is more attractive, it will stay bonded to the chlorine. Now, obviously, or maybe not obviously, if we had the situation reversed, if we had solid lithium and a solution of salt water, in this case, the lithium is higher up. This would replace the sodium, and we would have a reaction that would go like this. We would make lithium chloride aqueous plus sodium solid. Okay, so it does matter which one is bonded to the anion in terms of if the reaction will occur or not. So I'll give you some practice on iTunes U and see how you can do.